Thank you very much for having me. Thank you very much for coming. My name is Amit, and we're going to talk about sandbox evasion and sandboxes in general. And we're going to get to VBA referencing in a sec. The key principle I'd like you to leave from this talk is a new approach to sandbox evasion, and we'll get to it. So, as I said, my name is Amit. I'm a security researcher at Votiro. I'm from Tel Aviv, Israel. 28 years old, working for Votiro for the last year, and before that I was working at Checkpoint, researching, studying exploit kit as part of the threat intelligence group. I like skateboarding, swimming, and I play the guitar. And my co-researcher in this presentation is Aviv, who couldn't be here today. He's the CEO of Votiro, and unfortunately he couldn't come. So that's it. Let's begin. Okay. So sandboxes have become very big in the industry, right? Most organizations use them nowadays, and it's heavily trusted. I mean, once a file has passed the sandbox, you can pretty much trust that it's safe, and you can execute it in your environment, in your organization, and everything. Ever since sandboxes have begun to appear, malware authors have begun to use sandbox evasion techniques to bypass that sandbox. And so it's a never-ending process, and we're going to talk about a new way to perform sandbox evasion. Unlike most of those techniques, those sandbox evasion techniques, we don't require code execution. And I'm going to show how we do it and detect and evade the sandbox without code execution on the sandbox. Actually, the detection part is server-side, at the attacker side. Just a few notes. I'm going to jump between topics. I'm going to start with sandbox evading techniques and then talk about VBA referencing. So in order not to get confused, we've added these two icons just to clarify where we are. So if we're going to talk evasion, I don't know, do you see this little marker? So this little guy is going to show evasion parts, and this magnifying glass, we're going to show the detection scheme. Usually, when talking about sandbox evasion in relations to Office and Office documents and stuff, the following topics might come to mind, but we won't go into them extensively, just a bit. So if you have any questions, just feel free to come and ask me after the presentation or email me and everything. So we won't go into VBA macros, VBA Visual Basic for Application macros, and Office Protected View, sandbox solutions in general, and tracking pixels. But as I said, feel free to approach me and we can discuss those later on. Okay then. So, evasion. Notice the little guy. So, with the introduction of sandboxes in organization, malware authors have introduced sandbox evasion. And that's pretty much a term used to describe every way to detect and evade and manipulate and trick a sandbox, literally. Any way you can do to bypass the sandbox. And there are a lot of techniques, and they have been used and updated along the years. We're going to go through some of them quickly, just as a reference. And this information came from a very good presentation countering innovative sandbox evasion techniques used by malware from FIRST conference last year in Amsterdam. So in order to detect the sandbox, I can look for virtualization products. I mean, usually a sandbox is a virtualized machine that's executing the file, analyzes it, and then shuts down, reverts. So I can look at the hypervisor, and I can try to understand which hypervisor is it. Is it the physical machine? Is it a virtualized machine, for example, a VMware or VirtualBox? I can look for relevant virtualization DLLs, exactly the same. I can look at side channels attack and try to compare between a physical hardware and a virtualized hardware. Or I can look for unusual hardware in the machine, for example, low RAM memory or low disk size. I mean, something that's not usual for a user to be using. Another thing I can do to detect the sandbox is look at the environment past the the hardware or the virtualization, I can look and try to detect whether this is a genuine user actually running this environment. What's the username? Does it have cookies or browser history, recent file count? What's the screen resolution? I can look for running processes and try to understand if it's actually a security researcher that's executing my malware. I mean, does it have Wireshark running, or Process Explorer, or Process Monitor? I mean, if I see these processes, I might not want to infect. And the final technique to detect a sandbox is actually look for old vulnerabilities. I mean, if I scan the environment for a very old vulnerability and I find it, it exists in the machine, it means that this machine hasn't been updated in a while. So it's not a likely scenario for a user, and I say, if it has this vulnerability, I might not want to infect this machine because it might be a sandbox. This tool is called Paranoid Fish. I'm guessing most of security researchers know it. It's used to, it's aimed to use by security researchers to test their sandbox environment. You execute it within your machine, and it tries to detect the environment, all sorts of stuff that we talked about. It looks at the hypervisor, it looks at the username, mouse activity, disk size, RAM size, side channel attacks, and so on. So that's for detecting the sandbox. And now, if I want to evade the sandbox, most used techniques divide into maybe defeating the monitor. I mean, if I have a sandbox solution and I know it, and I know how it works, I know that it hooks A and B and C, I can either remove these hooks, or I can go around them, or I can delay execution using sleep or counting Fibonacci numbers until the 5,000 number, whatever. So that's one way. And another way is to be context aware. For example, a sandbox is usually a virtualized machine, an automatic one, so I can require code execution. There was a very cool sandbox evasion technique that required that you hover a text in a PowerPoint presentation, and as long as you didn't do it, nothing happened. And same goes for check date and time to see that it makes sense, and encrypted payloads. So all of these techniques require code execution for them to work. So you have to get your code running in the machine, in the virtualized environment, in the sandbox, in order for you to collect the information and then decide if it's indeed a sandbox or not. So there are two takes from that. If you did not obfuscate your code, if it's just plain code, then static analysis tool can analyze your code and then decide, okay, whether this is suspicious code that's trying to detect the machine or not, and then flag it accordingly. And if you did obfuscate your code, eventually it will be executed in the sandbox, which are now aware of these techniques that are trying to bypass the sandbox, and the sandbox will block it, flag it as suspicious, as trying to evade the sandbox. So we have a never-ending process. So sandboxes began blocking malware who detects sandboxes, and now it keeps on going. And as I said, we're going to use a technique that doesn't reveal to the sandbox that we are trying to identify it. And in order to do so, we will be discussing VBA referencing. So VBA, as I said, Visual Basic for Application. It's a very old concept of Microsoft. It was written a long time ago. And let's just say that security was not the main issue when this feature was developed. We're going to see in a second. So in order to truly understand what VBA macros are capable of, you have to look in the MSO VBA document issued by Microsoft. It's the documentation for the Office VBA file format. It's a binary file that hosts all of the capabilities of VBA projects. And for example, if we talk about Office products and Word and Excel and PowerPoint, they have the capability of hosting, embedding these files within. Usually they're called VBA project.bin. And this is the relevant file that hosts all the malware, all the macros, and the VBA capabilities. And the malware, yeah. So we went digging in this document, and we actually weren't the first one to dig in the MSO VBA documentation. A few years ago, Mr. Heifei Li, in his presentation, the analysis of attack surface of Microsoft Office from a user perspective, he showed that a feature of the VBA file. There is a feature that enables you to load remote automation type library and actually fetch it, load it, and execute it. And he was able, in here, by the way, you can see this is the image from his presentation. And this is the field where you can specify the path to the automation type library and which will be loaded. And actually, he tells the story how this vulnerability was discovered in 2008, I think, and Microsoft didn't mind. And eventually, he was able to show that you can actually hijack the program flow and actually achieve code execution. And eventually, this was fixed. Microsoft patched this, and it's no longer available. But we did something similar. We went to the document, and we've read it, and it's 111 pages. It's not that nice. And we actually found something else. And what we found was another section that's called project references. And it allows you to simply fetch a remote VBA project and use it as your own, use that code as your own, simply a reference, just like any other programming language. I'm guessing that was the point of this feature. And you can point to several VBA projects as well and use all of their codes as well. So this is what it looks like. This is just the title this is just the content from the documentation. And if we zoom in on this is from the examples of the documentation. If we zoom in on this, you can see the offset and the byte size and what it says. But basically what we've noticed is this. We saw a path, and we said, okay, that's interesting. What's this path? What can I do with it? And apparently, it doesn't matter if it's a relative or an absolute path, if it's a local path or a remote path. As long as it's available, Office will fetch it. Once the VBA engine loads, it will fetch it, and it will include it in your code. And then you can use it as your own. And we thought that this was quite interesting, and we've decided to explore a little bit. And this is what it looks like. So because it's VBA and Office uses VBA on every day, I guess, and most users use Office in their daily activities, we thought that Office would be a good attack vector. So we started testing, and we've tested this across several products. So let's see how Word behaves when we get VBA referencing active. So you open the document, and protected view blocks this feature. But once you enable it, you get a weird message, and protected view enabled again. And then you block it, and you get no error. But what I'm trying to say is that this is not predictable behavior. As an attacker, I cannot rely on Word documents to be silent when I'm trying to use VBA referencing. And actually, if we do this again, you can get another message. This is a completely different message from the one that I got before. So Word, not reliable. I'm not going to use that. Moving on to PowerPoint. It looks fine. It works fine, but it gives you this message to the user every time he opens the document. And it's a security notice. It's not the poor protected view yellow bar. It's a big message, and you simply click disable macros, and you're done. So PowerPoint, out of the equation as well. And eventually, we got to Excel, and Excel, it's just perfectly suitable for this attack, I guess. You open the document, you enable content, and you get code execution. And this code was a message box in VBA, and I'm guessing some of you know what's the syntax of message box in VBA. And in this document, this is the code. So no message box, hello world, anything. It simply says call me function, and this function is not available in this project. It's actually in this project. And the funny thing about Microsoft products is because there are so many divisions and teams, and they have the Word division and PowerPoint division, is that we have similar products that behave differently. So Word and PowerPoint, not going to do it, but Excel will be doing it. And so what we've learned so far is that we can use VBA referencing, and Excel is probably the most likely candidate for us to use as bad guys, and that most sandbox evasion techniques rely on code execution, which is nice, but we want to take it a step further. So let's make something out of it. Now that we know that VBA projects can fetch from another VBA project, we can use it, right? We can craft a document that has benign code, for example, call me, that does nothing, and it tries to fetch another VBA project. And once this VBA project has been fetched, it will execute the code. So my document will pass static analysis tool trying to detect my VBA code because it has nothing. It has call a function that doesn't exist. But eventually, once this code gets executed, the sandbox will block it. So I'm still halfway there. And we thought that it will be even cooler if I can decide as an attacker and if I can detect who's asking. And if it's a sandbox asking me for my remote VBA code, I will answer in one way. And if it's a user asking, I will answer in another way, if I can detect them reliably. So how can we do it without code execution? And before we talk about that, just a final note on sandboxes. As I said, we're not going to go into it, but sandboxes are heavily deployed, as I said. And their purpose is quite simple. They take each incoming file, according to some policy, and they let it execute in their safe and virtualized environment. And because each file is inspected, you have to give it a certain time limit. You have to make some adjustments in order for the sandbox not to become a bottleneck and not to clog your traffic. So first of all, it has to be automatic. I mean, no user interaction required, no nothing. If the user got the file at the end of the day, then that file has passed the sandbox and it's safe and you can open it and no problem. And second of all, it has to be fast. I mean, if you have thousands of files each day entering your organization, each file takes 5 or 10 minutes to execute, you're going to clog your network. So you have to set a time limit, and you have to have optimizations at the virtualization level, and so forth. And the final point, which is, I think, the most important one, is the secureless feature. It kind of supports the two features above, in the sense that it's a sandbox environment. It's virtualized, it's in a different segment of the network. If anything happens to the sandbox, nothing will happen. So the general concept of the sandbox is to let the malware execute as freely as possible in order for it to see what the malware does and then make the best decision it can make. So you drop all security mitigations, Windows Defender, Windows Firewall. In case of Office, you drop the protected view in order to make things faster, so you don't have to disable them manually or by code that will cost you some time. And you can actually see what the malware is doing completely. So building on these points, let's look at the difference between a sandbox and a user. So when a user opens the document, Office document, for example, usually they have protected view enabled as a group policy in the organization or other policies. So the user opens the document and it has to disable protected view in order to load the VBA engine. Once the VBA engine has loaded, VBA referencing occurs eventually. And most users click through the protected view without thinking about it. Regardless of social engineering attacks, most users just click it anyway. So this is a user. And if we look at the sandbox, having being automatic and fast and secureless, we have protected view disabled. And once it's disabled, the order is different. So you open the document, that's the same, no protected view. So once you open the document, the VBA engine loads immediately, causing the VBA reference to happen at the same step. But you didn't have protected view enabled, so we can actually spot the difference between a sandbox and a user. And we're going to rely on it. And I just want to make a few points about protected view. Most people think that it's aimed to block malware. Again, macros, sorry. And it does. It actually blocks the VBA engine completely until you allow it. But it's not just for macros and it's not just for the VBA engine. It actually has a lot of capabilities. And it blocks other elements in the document as well. And I'm going to show you. This is from the documentation. And this is one of the sites discussing why protected view is blocking images for the user. And let's enlarge that. They're talking about images. If you have an embedded image in a document that you've received, and it's a linked image, once you open the document, that image is being fetched, and that can signal the attacker that you opened the document, and it can send all sorts of information to that remote server. So this is why protected view blocks all of these. Images in Outlook, the linked media, and the data connections. And so if, as a user, I have protected view enabled, in order to truly protect me, it's actually using a two-step confirmation scheme, let's call it. So I open the document as a user, and first, Office Protected View allows me to enable all of the suspicious internet files, but that they are less dangerous to me than active content. This is the first prompt that you'll get. Files from the internet can contain viruses. Do you want to have them? Do you want to enable them? And this will load the non-executable objects, the images, what we saw, the linked media and data connections and so forth. So you click Enable Editing, and once you do, the document loads all of these elements, and then it asks you, do you want to load the active content? In this case, macros, but it could be ActiveX and so forth. So as I said, it's a two-step confirmation procedure in order to protect the user. First, you load the suspicious stuff, and then you load the actually potentially dangerous elements. So this is the user's point of view. And if we look at the sandbox point of view, it's actually completely opposite. Because we don't have protected view enabled, once you open the document, it will immediately load the VBA engine. You won't be seeing this message because protected view is not enabled. I'm just showing it here so we can get the order right. So no protected view. You open the document in the environment, in the sandbox. The document loads, and VBA engine loads immediately, causing VBA referencing. And once the document has loaded, VBA referencing finished and everything, then it will load the rest of the content, the images, the text. Effectively, this is what we would have seen if the sandbox would have shown these prompts. So we can actually see that this is completely the opposite. Enable content and enable editing in the sandbox. And here we have enable editing and enable content. And we actually plan to use this difference for our advantage. And we're going to use some sort of tracking pixel as a baseline. I'm going to get into it in a sec. You're going to see. So once we've built all this scheme, we can actually detect a sandbox or a user quite efficiently. So this is the detection part, and this is what it looks like. When the document is being opened in the sandbox, this is the flow we're going to get. So document open in a sandbox. This is the document. Immediately, no protected view, so the VBA engine is loaded, causing VBA referencing to occur, fetching the VBA project from the attacker's machine. This finishes the loading of the document, and now the document continues with the other elements. In this case, it's the image, and it loads the image from the attacker's machine. This is nice. And when a user is opening the document, we have protected view, which is this, what this lock symbolizes. And the user opens the document, and everything is blocked. This is protected view. And it asks you, do you want to load the suspicious internet files first? If you do, please enable editing. If you don't, I won't be loading anything. The document is blocked. And if it only contains, for example, a linked image, then you won't be seeing anything. So the user clicked through it, and actually the image is loaded. And now the user gets the second protected view warning about active content. Do you want to enable active content? And the user quite naively clicks it, loading the VBA engine, causing the VBA referencing, and fetching the code. So we can actually see a difference between a user and the sandbox activity. And this is our detection scheme. I'm going to show it from the attacker side in a sec. But note this. We have from the sandbox code requests and then image requests. And on the user side, we have image requests and then code requests. And I'm going to build on top of that. So as an attacker, I am hosting both the remote VBA project and both the image as well. And I've created a document that contains these two elements and tries to load them. And now I'm sitting on the attacker side, intercepting the requests, and I'm trying to decide whether it's a sandbox or a user. And I'm looking at the request, and I'm saying, okay, if I'm seeing requests for the VBA code before I'm getting requests for the image, then this must be a sandbox, because the sandbox is asking for the code and then for the image. And if I look at it in the other way and I'm seeing requests for the image and only then requests for the VBA code, then I can decide that this is a user. So far, detection. Now moving on to actually evading the sandbox. So I have a verdict, right? This piece of code decides whether it's a sandbox or a user. And now I'm going to build on top of that and say, okay, I have a verdict. If the verdict says sandbox, I'm going to reply with a benign VBA project. And if it's a user, I'm going to reply with a malicious VBA project. So the attacker simply intercepts the request, and now he has to respond. And he has two versions of the requested VBA projects, and according to the verdict, he decides, is it going to be benign or malicious, depending on the verdict. So if we look closer, this is what this attack looks like. From the sandbox side, he opens the document is open, no protected view, VBA engine loads, causing VBA referencing. The attacker looks at this request and says, okay, I'm seeing requests for VBA referencing, no previous requests for images. I'm going to reply with the benign piece of code, the happy face. It's happy because nobody will be upset if he got it. So that's the attacker's response. The document is now loaded, and it continues fetching the other elements, in this case the image from the attacker's machine. The attacker simply replies with the image, and we're done. So this is a sandbox. And the sandbox got the benign piece of code. He suspects nothing. The original document has nothing bad in it. The fetched VBA project has nothing bad in it as well. Nothing to suspect. So he passes this document to the user. And this is what it looks like from the user's point of view. So the user opens the document, and once again, protected view. He enables editing, causing the image to be fetched. And now the attacker marks the image and says, okay, I saw requests for the image. I'm going to remember that. And responds with the image. Once the user clicks enable content, causing the VBA engine to load and VBA referencing, sorry about that, the attacker gets requests for the VBA code, and now he has to decide, have I seen requests for the image before or after? And he says before, meaning that this is a user, and he will reply with the malicious benign project, the bad, the sad face. So this is the detection and evasion scheme. And demo, right? Hopefully. Okay. So this is the attacker's machine, and I'm going to run the intercepting code as well. And one final thing, I don't have a sandbox on this machine, so I'm going to run this document 2 times. The same document trying to access the attacker's machine. And this document is already trusted. The thing to understand about protected view is once you trust the document, it's trusted until something happens. And usually what happens is if you change the name of it, it's no longer trusted. This means that the path is considered trusted for the document. So I've been playing with this document. As you can see, I'm always adding a digit after I've tested it. So I've tested it a few times. And this should open in protected view. Okay. Fortunately, it opens on my screen, so I'll have to show it to you like that. So it opened on protected view. Without protected view, nothing interesting happened. And if I open the VBA project, you can see that the call me function is actually empty. And it's in this module, in the refme project. So empty function and empty project. And now let's change that Okay. And as you can see, the attacker has identified that this is a sandbox, and he replied with a benign piece of code. And now, let's run it again just to be sure. Okay, and now I have this document here, which is in protected view mode. So the image is not loaded, I can't see anything, yet the user would simply click this enable editing, causing the image to load. So nice, the image is loaded. With this image, I could have used the usual social engineering scheme of this document is out of version, please click enable content to truly view the document, and so forth. So now, let's try to enable content. And we get this. You've been hacked. Sandbox Evasion, right? Okay then. Thank you. If we look at the code, the previous RefMe project was empty. Now it contains a user form, which is the you've been hacked form. And if we look at the code module, we can see that it shows the user form. It could be anything, right? This is code execution. You could access the file system, you can use Windows API, and so forth. So let's get back to this. I've actually prepared a video in case the demo didn't work, but lucky for us, it did. So this would have shown the attack using the Cuckoo sandbox and how it bypasses and what's the verdict, but yeah, moving on. So we've tested this attack against 7 leading sandboxes solution, commercials and open source. We won't be naming anyone, but all of them were evaded. So none of them has flagged this file as malicious or sandbox evading suspicious or whatever. The file ended up at the user, which is something to consider in regards to sandbox, because most users consider sandbox as a bulletproof environment. Whatever comes through it is safe, and eventually we can see that it's not the case. We've noticed some key points when we investigated this technique. Some sandboxes, whether they are deployed in organizations or just their deployment as a product over the internet, block SMB. And that makes no sense, right? It's even better for me as an attacker. For example, if I rely on SMB in this attack and you block SMB, the document would be even more benign because it doesn't fetch anything. We have a benign document that's doing nothing, and the sandbox will pass it on to the user. And now I get my chance. If the user hasn't blocked SMB in this case, then by all means I can infect it. One other thing is that some sandboxes don't inspect, they don't block SMB, but they don't bother to inspect what's coming on SMB. And as we've seen, we had a VBA project going inbound through SMB, and you can inject whatever you want into a VBA project. I mean, you saw the user form. I can put images inside. I can put text inside. I can base 64 encode a piece of code and then execute it, bypassing all sorts of static analysis tools if they do bother to inspect. So I can inject a lot of stuff to a VBA project. And if you don't bother to inspect them, then you will be missing out. And some other things to consider is that this is not the only scenario. Yeah, we use protected view and we relied on VBA referencing, but PDF has its own protected view and it has JavaScript within. So I haven't tested it, but I think this sounds like a solid research to go to. And okay, so let's talk about mitigations. So first of all, and the most obvious one, if it hasn't been clear so far, you have to block SMB and FTP, which should work on this attack as well, on the user, inbound and outbound. You can't have the user communicating with somewhere remote on SMB, and you have the pass-the-hash attacks and stuff like that. You don't want that. But you do want to inspect SMB on the sandbox. I cannot stress this enough. You want your sandbox to be as loose in security and as enabling as it can to allow the malware to truly execute. What you might want to do is look at your environment, your sandbox environment, and see what you can fix in that environment to not allow this attack. And it's usually at the vendor, that's usually something that the vendor should do. They should look at their environment and their analysis machine and see how they can fix their environment to prevent these detection schemes. And it will cost you. I mean, there is a trade-off. If you enable protected view back, it will cost you in time, and you have to develop a specific module for that. But, I mean, as we've just seen, this has bypassed a sandbox, this attack. You might think that I'm too harsh, but I say simply restrict internet access from Office altogether. I don't see a point for a Word document to access the internet and fetch something. I know it can do that, and it made sense in the 90s, I guess, but it doesn't make sense anymore. And in 2017, last year, we had, I think, 4 0 days regarding Word, accessing the internet, fetching something bad that gets code execution. So there's no point in my book. And the final thing which you can use is CDR, which is content disarm and reconstruction. And you simply switch from detecting the threat to disarming it. You have a file, it gets into the disarmer, it sanitizes it, and the end user gets a clean file without the detection scheme, without the time. Less time, less effort, and eventually a clean file. So let's sum up. We've discussed sandboxes and how they dismiss security mitigations, and in this case, how they dismiss protected view in order to not become a bottleneck, which is cool. But we built on top of that, alongside VBA referencing, which allowed us to fetch code from something else. And these two combined allowed us to actually bypass the sandbox, because we could spot a difference between the user and the sandbox. And I think it's important to stress out that we didn't break anything. We didn't look for a vulnerability in VBA referencing or in VBA as a general. We didn't target a specific sandbox or a specific vendor or a specific product within a sandbox. This is more of logical abuse. I mean, I know that the sandbox don't want to become a bottleneck, so they take these steps in order not to do so. The user takes different steps, and so I can detect between them. And the main points to take from this talk, as I believe, is if you can identify key differences between a sandbox execution and a user execution, you can achieve sandbox detection. You can detect quite reliably what's a sandbox and what's a user according to these differences. And in this case, we've combined it with code referencing or fetching remote references or text, it could be even, to achieve sandbox evasion. And because sandbox evasion is so heavily relied on these days and so trusted, once you have bypassed the sandbox and evaded it, it will most likely end with the infection of the user, because it trusts the sandbox so much. And that's it. Do we have questions? Anyone?
Did you ever see any kind of benign usage of referencing in any document whatsoever?
I mean, I guess I'm always going to the 90s because for some reason VBA was very popular in the 90s, and it was being used to fetch information from sites and all sorts of stuff. I haven't seen legitimate uses. I'm guessing what they were aiming for is just like, okay, programming languages can fetch and reference code. This VBA is a programming language. It should be able to reference code. I think this is what they were aiming for.
So basically, any use of this feature should be flagged malicious with pretty much low false positive rate.
Sorry?
So you could just flag anything which you statically detect has this reference field not empty as malicious, just with a pretty low false positive rate, because, well...
I go the extra mile and I say block Office Internet Access altogether. If you want to do that, yeah, you can actually flag, in my mind, you can flag documents or VBA projects that trying to fetch something from the internet and say, yeah, this is suspicious by my book. And I think you'll be fine, because I haven't seen, and I'm guessing people in the audience haven't seen legitimate cases of VBA referencing something.
Did you try to collect like a big data set of documents and see if any document uses this in the wild, maybe?
I haven't. I looked online to see if there are references in regards to malicious behavior or just general behavior. And the last things that I saw was from 2005, 2006, people asking in forums how to use VBA referencing, but no solid evidence to malicious activity, for example.
Thank you.
Yeah, no problem.
So very interesting research. You mentioned you have tested 7 different sandbox products. Did you reach out to the vendors and explain your research to them by any chance?
No, actually some of them contacted us and we've shared what we could share with them. But this is not a specific vendor related issue. It's a general issue with the sandbox, with the concept of the sandbox and how it's being implemented. So there's no point reaching out to anyone. I'm hoping that this presentation will do the work instead of reaching out to anyone. Okay. No more questions. So that's it, guys. Thank you very much for listening.